Hey, that looks hard. Oh, okay. So now this one we kind of did in class. We have to perform the following expansion, and we're given for 27 4 plus 9i squared. So this is a real number, or a real component and an imaginary component, but we're really just going to kind of treat it like a binomial expansion. So this means 4 plus 9i times 4 plus 9i. So I like to use the grid method when I multiply binomials, or any polynomial really. And then I'm just going to take my 4 and then my positive 9i and write it that way, and then 4 and positive 9i. And then I multiply the row by the column. Okay? So the row is 4 times 4, which is, and I'll just write it down small so you can see it, 16. Then I'm going to have, so this is the answer, 4 times 9i, bless you, is 36i. 4 times 9i is 36i. And then 9i times 9i is 81i squared. Now we've got to remember that I squared is equal to -1. So if I write this out in the next step, I'm going to say 16 plus 36i plus 36i, right, plus 81i squared. But what did I say I squared was equal to? -1. So I'm going to replace the I squared with -1. So what that becomes is 16, 36 plus 36 is 72, and then this becomes minus 81. So again, what we have is anything with an I is imaginary, anything without an I is real. Right? And so this is the real component. This is the real component. And anything with an I is an imaginary component of a complex number. So I just need to combine the real components. So what is 16 minus 81? So you want to do that on the calculator? It is 65, right? Yeah, thank you. It's -65 plus 72i. And remember, we always want to write this so it looks like a plus bi, right? That's how we always want to write it. We want to write the real component first and the imaginary second. I suppose, so I don't confuse you guys, maybe I should write the imaginary like that. I'm just coloring. There's 2 reasons I became a teacher. 1, I get to color. 2, school lunches.